So, a very good afternoon. We will little bit revise about unit number 2, whatever we have seen, and then afterward we'll start with unit number 3. So there will be 2 hours lectures today. So little bit of hectic thing, but you have to manage. As this semester is a very small semester and we have to cope up with the things, we have to take it a little bit faster, as well as we have to go with a lot of data. So we will be revising this unit number 2, and then we'll start with unit number 3. So we started with the unit number 2, which was about the problem solving through search. So we have seen different search techniques in this unit. So let us see one by one what we have seen. Where is the problem solving through search method is utilized? That is the most important thing. In today's actually fast-paced digitized world, the artificial intelligence techniques are widely used in automation. As we know, it can use resources and time very efficiently. And henceforth, this problem solving through search can be used in different applications. That may be search, Google search. That is one of the things. Then the other things is in everyday life, we can be using in games and puzzles. And by using this AI technique, actually it is one of the part where you can use these problems efficiently. The most common problems that can be resolved by AI are traveling salesman problem, Tower of the Hanoi problem, water jug problem, NQN problem, then chess, Sudoku, crypt arithmetic problem, magic square, logical puzzles, and so on. These are the some of the use cases of an AI as far as search techniques are concerned. Now, what are the steps that is to be followed through problem solving through search? So there are 5 common steps that are included in it. First is defining the problem. These are the steps which are actually applicable for the project also. When we do project, we have to do such kind of things, right? Only one thing will be added here is the results and discussion. Otherwise, the 5 things that are given are nothing but the 5 chapters which are included in the thesis or in the project or in the project reports. So what are the 5 steps that are used for problem solving through search techniques? Define the problem. Obviously, you define the objectives as well as problem. Analyze the problem, identification of the possible solutions. What are the possible solutions that you have to see? Then choosing the optimal solutions, and then the implementation. And rest is the conclusion as well as results and discussion. These are the things that are included normally as far as the search techniques are concerned. What are the properties of search algorithms? So we have seen 4 properties of search algorithm. First one is the completeness. So when it gives a solution or returns any solution for a given a random input, it is said to be as completeness. Optimality, if the solution found is best amongst all the identified solution, and that solution is an optimal one, then we say that it is an optimality. Time complexity, that is the time taken by algorithm to complete this task, is the time complexity. If it is completed within a very less time, then it is said to be as more efficient. Space complexity is very much related to the maximum storage or the memory at any time while searching. And these properties are used to compare the efficiency of different types of algorithms. So time complexity and space complexity are very two important properties of the search algorithm. Then we have seen types of search algorithms. So basically there are 2 types. So one is an uninformed search and the other one is as informed search. So uninformed search do not have any kind of a domain knowledge. Then it is also called as a brute force kind of algorithm or a blind search algorithm. And the most important thing is that it knows the information about how to find the goal state. So with the help of information, it can easily find the goal state. Then there are 6 categories of the uninformed search. The first one is a breadth first search, depth first search, depth limited search, iterative deepening deep first search, bidirectional search, and uniform cost search. Now, the breadth first search is one of the most important categories. It actually deals with the root node and also examines the neighboring nodes and moves to the next level. The basic strategy that is used by the breadth first search is a FIFO, that is first in, first out. BFS is used where the given problem is small, the space complexity is not considered. So this is the example of the breadth first search. So let us take that A is the initial node and F is the destination node. So A will travel to the next level, that is B and C. And then it will travel to the next level, that is D, E, F, and G. The goal state is defined as F. So it will stop at F. So how it will go? So obviously the A will travel to B. From B, it will go to C. From C to D, then to E, and then to F. This is how the path is considered about the breadth first start. What are the advantages? It may be trapped in unwanted nodes. Then if the graph is having more than one solution, then it will provide you the shortest path. These are the advantages. Whereas the disadvantage is that requires a lot of memory to store the nodes because it goes to each and every nodes. And it takes more time to reach to the goal, which is far away. Then second one is the depth first search. So as far as depth first search is concerned, it operates on LIFO, that is last in, first out. So again, let us consider A is the initial and F is the destination node. And as we know that how DFS works out, it starts from the left node and then from root node to the left node and then to the right node. So if we go by A, now from A, it will travel to B. From B, it will go to D. After reaching D, it will backtrack to B. B is already visited. Hence, the next step will be DE. And from E, it will go to B. From B, it will go to A again. A is already visited. So now it will go to C and then F. So if we look at the F is a goal state and it will stop there. So how it will go? It will go from A to B, D, then it will go to E. Now it will not go to B and A, right? So while traveling the route, it will not consider B for backtracking. It used it because it knew that B and A is completely utilized. He has reached there, and henceforth after E, it will directly go towards a C and then F. So this is the depth first search. So it takes lesser memory as compared to BFS. The time complexity is lesser as compared to BFS. So DFS is does not require much more search. So जैसे हर एक नोड हर एक नोड के ऊपर जाना पड़ता था ब्रेडथ फर्स्ट सर्च में, वैसे डेप्थ फर्स्ट सर्च में कुछ हद तक कम नोड्स पर जाते हैं. Some of the disadvantages that not always guaranteed to give a solution. Then it may be trapped in the infinite loop. Then the depth limited search. So depth limited search is very much similar to the depth first search. Here the depth limited search solves one of the drawbacks of DFS, that is not going into the infinite path. So DFS search is having the issue of it may go to the infinite path, but the depth limit search will limit it. The DLS ends its traversal if one of the conditions is followed. अगर दोनों में से एक कोई भी conditions follow हो जाती है तो वो रुक जाएगा. One is the standard failure, that is denotes the given problem does not have a solution. अगर उसको कोई solution नहीं मिलता है तो. And second is there is no solution problem within the given limit. So एक उसको solution ही नहीं मिलता है, दूसरा particular limit में ढूंढते रहेगा लेकिन उसको मिलेगा नहीं. So अगर दोनों conditions satisfy होती है, तो हम बोलेंगे कि depth limited search है. So depth limited search कैसे काम करता है? Obviously it will be working, it will categorize into 3 levels. So first one is a limit 0, limit 1, and limit 2. So A is the initial state and C is the final state. So what will happen? It will start from limit 0, that is A. Then it will move towards the limit 1. So in limit 1, it will search out the destination node. So as soon as it sees C node there, so A will reach to the C. Right. Now, suppose if we consider that goal is C and limit is 0, then the algorithm will not return any path and hence the goal node is not available within the given limit. Second thing, if the goal node is F, let us suppose F and limit is 2, then what will happen? The path will be A, C, and F. Now, what are the advantages? Lesser memory as compared to the other search techniques, gives an optimal solution and encounters incompleteness. Incompleteness यानी कि हर इनपुट को आउटपुट जाना चाहिए मगर कभी कभी आउटपुट नहीं जाएगा, तो उसको हम incompleteness बोलते हैं. Then next one is iterative deepening depth first search. So this is again a type of algorithm which is mainly based a combination of depth first search and breadth first search. So here it will be again having a limits. So consider A and the goal node is E. The maximum depth is considered to be as 2. So it is not found. It goes to first, the algorithm will start with A. It will go to the next level, B and C, it will not find there. Then it will go to the next level and finds E. So the path traversal will be A, B, and E. Now, bidirectional search, it is different from all other search techniques we have seen. It executes two simultaneous searches called as forward search and backward search. So यहाँ पर forward और backward search दोनों एक साथ होते to reach the goal state. What does it have? Sorry. What does it do is that it divides the graph into two subgraphs. One of the subgraph, it will start the initial start. It will start from initial state and reaches to the goal state. And in the other graph, it will start from the destination node and it will reach to the initial node. So the point where both of them intersects with each other, there it will terminate. So in this way, it starts from both start as well as goal state and well-defined branching factor to be the same in two directions. This is how the bidirectional works out. So you can see that the graph is divided into two subgraphs. So what will happen is that in one of the case, it will start from E, that is the starting node. And in the other graph, it will start from G, which is called as the destination node. Now, when it will start from E, the first will consider the path of the traversal E. So from E, it will go to B, then to A. This is the first subgraph. So from E, it will go to B and then it will go to A. Now, in the second subgraph, it will start from G. So it will start from G, it will move towards C and then it will go to A. Now, both of the subgraphs meet at A and hence the graph will terminate. Hence, we can say that both the transversal meets at A and hence the traversals end. Is it right? So how will be the path? The path will be E, B, A, C, and G, where A will be the point of termination because both of the graph meet at A. Advantages: the algorithm searches fast. It requires less memory to complete its action. But disadvantage is that goal should be predefined and the graph is little bit difficult to implement. So this is nothing but the bidirectional search. Now comes a uniform cost search. So in case of uniform cost search, if you look at the algorithm, it is search algorithm for the weighted graph. So there are 4 loops: SAEF, SBEF, SCDFG. So if you calculate the weight, it will come to know that the S, B, E, F, and G is having the lesser weight, which is equal to 18. And hence the path of least cost will be S, B, E, F, G. Advantages based on low cost. Disadvantages: it goes to reach to the lowest path and it may have an infinite loop. Now comes informed search. It is also called as heuristic search or directed search. The goal state can be achieved by using the heuristic functions. It is having the lowest cost possible. Here, this function estimates how close a state is to the goal. And there are 2 types, mostly true strategies are there. One is called as a greedy best fit search algorithm and A star search algorithm. Now this is the greedy. It will be having the heuristic function like A equal to 13, B equal to 12, and so on. So how it will be going? So A, and let us consider that A is an initial node and H is the state node. So let us assume that it will start from A, examine the next neighbors B and C. So what is B? B is 12, C is 4. So in between 12 and 4, the best path of the C is C will be 4, because as it is a lesser value, it will move towards a C. So first case will be solved as C. Now from C, it explores to F and G. What is F? F is 8. What is G? 2. So C will go to G because G is lesser weighted. Now from F and G, automatically it will go to H because H is 0. So how will be the path? The path will be A, C, G and H. So you can see from here. Now comes A star search algorithm. It is a combination of both uniform cost search and greedy best first search algorithm. Advantages: having a better memory usage. Then it uses heuristic to find out the shortest path. And it is a sum of both heuristic as well as cost function to find out the best path. Now this algorithm is a little bit complicated. We cannot say it complicated, but yes, there are few things that is to be considered here. Is that we not only consider the weight but also considers the heuristic functions. Now let us assume from A to B, it will go from A to B. So B is 3. So A will be a combination of 1 plus 3, 4. Okay. Now from A to C, what is C? 4. So the C will be combination of 2 plus 4, 6. Is it okay? And then A will go to H. So that will be 7 plus 0, 7. So now what is happening? The lowest cost will be 4 and hence it will go to 4. So it will go from A to B. Rest of the things you can consider. Understanding? Now what will happen? From B, it can go to D or E. Now, what is the value of B when it can go to D or A? So A to B is 1, 1 plus 4, and D is 2. So 7 will be the value. Second will be 1 plus 6, 7, and E will be 6, 13. So 13 and 7, the lowest cost will be 7. So now it will hold up till this. So as we got this D equal to 7. Now from A, as we know that the path is C. Now from C, it will go to F and G. Now from C, if you consider C is 4. So it will go to F. So 3 plus F is what? 3 plus 3, 6. And this 2, 8. And this 2 plus G is 1. 3 plus 2, 5. So it will be 8 and 5. So which will be the shorter way? It will be 5. So the lowest cost is 5. Now from G to H, will be 2 plus 0 plus 2 plus 2. So it will be 6. So the 6 is the lesser than other paths could be which is on the hold. And therefore H is the goal state achieved. The algorithm will terminate here. So what will be the path? The shortest path will be A, C, G, and H. This algorithm is best when compared to the other algorithms, and it can solve very complex problem and it gives an optimal one. Some of the disadvantage based on heuristic and cost, which may not produce shortest path sometimes. The memory is more as it keeps all the nodes in the memory. This is the comparison. So uninformed is a blind search. It is also, whereas informed search is heuristic. Uninformed does not require much information, whereas informed domain specific details is required. Compared with uninformed, informed search strategies are more efficient and time complexity of uninformed is more. Informed search handles the problem better than the blind search. This is the difference between informed and uninformed. Then we came to the heuristic search techniques. These heuristic search techniques are dependent on a given heuristic capacity or cost measure. This technique doesn't generally ensure to locate an ideal or the best arrangement. It may rather locate a decent or worthy arrangement. We regularly exchange one of the optimality, culmination, exactness, or accuracy for the speed. It takes the present state of the agent as its input and produces the estimation how close the agent to the goal. Why we need heuristic? That is the most important. So it is used in the situation where there is requirement of a short-term solution. On facing complex situations with limited resources and time, heuristic can help the companies to make quick decisions. Most of the heuristic methods involves mental shortcuts to make decisions on the past experiences. They can be different heuristic methods that correlate within the problem scope. The most common heuristic methods are trial and error, guesswork, in the process of elimination, historical data analysis. Then the simply available information that is not particular to the problem but must be accurate. So the methods involve simply available information. They include representative, effect, and availability heuristics. So there are different 4 types of heuristic methods that are implemented: hill climbing, constraint satisfaction problem, that is CSP, stimulated ailing, best first search, that is BFS. Whereas there are 2 categories of the heuristic search techniques. One is a direct and the second one is a weak. So now what is a direct and what is weak? So a direct heuristic search includes the blind search, or it we can say to be as uninformed search, and has a blind control strategy. Not always possibly requires much more memory and time. The examples of direct heuristic may be BFS and DFS. Whereas weak heuristic includes the informed search, it includes heuristic search, and the control strategy is heuristic control strategy. They require domain specific information. Now we started with hill climbing. So one of the best example of hill climbing is traveling salesman problem. Hill climbing is widely used when a good heuristic is available. It is a technique for optimizing the mathematical problem. It moves in the direction of increasing the elevation to find the mountain's peak, and hence it is called as the hill climbing. It is also called as a greedy local search, as it is a good immediate neighbor state and not yet beyond that. These are the algorithm. This is the algorithm for hill climbing in AA. So initial state, loop will terminate if there is no operator left to apply. Select and apply an operator to the current state, and the check then new state. If the goal state, if it is a goal state, then return to success and quit. Else if it is not, it will move towards, it will consider the new state as a current state. Or else if not better than current state, it will return to step number 2. And that is exit. BFS, a combination of DFS and BFS. It takes the benefit of both the algorithms. It uses the heuristic function as well as search. Steps. It will start with the starting node into the open list. If the open list is empty, it will return its failure. It will stop and return failure. Now remove the node n from open list, which has the lowest value of h of n, and then place it to the closed list. Expand the node n and then generator of the successor of node n. For each successor of the node, the algorithm will check the value of fn. If it could be in either open or closed list. If the node is not in both the list, it will add into the open list, and then return of the step 2. A star search, most commonly known as the best first search. It has both the states called as heuristic function h of n and a cost function g of n, that is from the start state g of n. This search algorithm expands fewer search trees and gives optimal results faster. It finds out the shortest path through the search space using heuristic function. So it will be quite similar to what the earlier algorithm we have seen. So it will start with the starting node and it will go into the open list. If the open list is empty, then it will return failure and then it will stop. When we select the node for the open list, it will have the smallest value of evaluation called is G of n. In that case, it was H of n. If node n is the goal state, then return success and stop. If the node n is already in open and closed, then we should attach to the back pointer which reflects the lowest G of n, and then we return to the step 2. In between, there is one very important step is that for each successor n, check whether n is already present in open or closed list. If not, then compute the evaluation function for n and place it in the open list. This is the most important step. Simulated annealing. It is an algorithm that never makes a move towards lower esteemed distance to be incomplete, then it can stall out to be nearby extreme. These are some of the heuristic search applications or examples as in everyday's life. One is a common sense. The second one is a rule of a thumb. Third is a working backward. Availability of heuristic. Familiarity of heuristic. Educated guess. Then the types of heuristic search. So mostly there are 3 types of heuristic search available. One is the availability heuristic, effect heuristic, and representative heuristic, as each of the heuristic plays a role in decision making. If we consider the availability heuristic, this is the decision made on the past knowledge of the experience of an event. It allows a persons to judge a situation based on the example of the similar situation that comes into the mind. A representative, we can be understanding with the help of product packaging. A customer tends to associate the product quality with an external packaging of the product. If the company's package is with the higher quality and well-known product, then consumer will relate the product to the same quality of the branded product. In this way, it can just correlate and can take the decision based on that. Effect heuristic, it is much more related with the quick feelings and past beliefs. It is one of the theory that is one of the emotional responses to the stimulus that can affect the decisions. Best example is example of advertisement. We can take example of the advertisement like consuming fast food that might decide the fast food as unhealthy, but people rarely take a time to evaluate everything they see and generally make a decision based on their automatic emotional response. That is where the advertisement is been carried out. Limitations of the heuristic techniques. Although we know that heuristic speed is a speed for decision-making process, and also it helps to solve the problem, but an error may be introduced because something may not work accurately in the past. That is, it does not mean that it will work again. It will hard to find an alternative solution or ideas if we always rely on the existing solutions of the hierarchies. Then we saw CSP, that is the constraint satisfaction problem. Consider a Sudoku game with some numbers filled initially in some square. So best example is the Sudoku example. Like there will be some empty squares as well as filled squares. You're expected to fill the empty squares the numbers ranging from 1 to 9. And the constraint is that you cannot repeat those numbers. So this is a very basic constraint problem, satisfaction problem. Now you're supposed to solve the problem keeping in mind that some constraints are there. The constraint is that you have to fill a variable and the range of the numbers is just 1 to n. The variable takes on values from the domain. The conditions governing how the variable will be chosen, its domain, are known as the constraints. And hence that requires its solution within some limitations or conditions are called as constraint. So you can give an example how mathematically you can correlate the constraint satisfaction problem. Here we can say that the finite set of variables are from V1 to Vn. Discrete values known as domain, that is D1 to Dn. And finite set of constraints from C1 to Cn. Now each one can involve any number of variables. So the condition is Ck, that is nothing but constraint. Power set of D, that is nothing but discrete value, which may be true or false, ranging from K as 1 to N. So the element in the domain can be both continuous and discrete. But in A, we generally only deals with the discrete value. Each variables in the variable set can have a different domain. Like in Sudoku problem, if we see that there is a row and column and block already have 3, 5, 7 filled, then the domain of the variables will be 1, 2, 4, 6, 8, 9. That is remaining values. So in this case, if you look at the problem, then we have a block already, which is nothing but 3, 5, 7. And the variables in that row column will be equal to 1, 2, 4, 6, 8, 9. So this is how the Sudoku problem can be solved by using constraint satisfaction problem. Some of the other popular problems with CSP are crypt arithmetic, NQN, map coloring, crossword, Sudoku, and a Latin square problem. CSP can be looked as a search problem. So that can be determining the set of all possible solutions, finding one that satisfies all the constraints in the search problems, like finding the shortest path between the two nodes in the graph. The search stops when we find a complete assignment that satisfies all the constraints. The constraint satisfaction check corresponding to the goal state in the general search. Mostly there are two types of the node in case of CSP as a search problem. The first one is nothing but the regular node that represents variable. And the second one is an hyper node that represents constraint. Then the stochastic search is a method of a choice for solving many hard combinatorial problems. It does not require gradient to guide the search, making them good fit for a discrete problem. Popular examples of stochastic search may be evolutionary algorithms, that is inspired by the concept of natural evolution, ant colony optimization inspired by the ant foraging behavior, and artificial immune system inspired by the immune systems of the vertebrates. The main advantage of the stochastic search is the heuristic that is being generally proposed algorithm. They can be applied in wide range of applications without requiring hardly any knowledge of the problem. In particularly given a stochastic search algorithms, it is unclear on which kind of problem it will achieve good performance. That is the problem with the stochastic. Even more crucial is the lack of understanding of how the parameter settings influence the performance of the algorithm. The goal of a rigorous theoretical foundations of the stochastic search algorithm is to answer questions of this nature by explaining the success or the failure of these methods in practical applications. Now, stochastic search algorithms can be also explained since the randomized algorithm make a random choices during their execution. So if you consider a heuristic, if you want to have a stochastic search, let us consider the heuristic function as A to optimize the function F. That is a random variable. So T will be A comma F. So in this example, you can see that the expected runtime is E T A comma F. So the efficient heuristic is a blue versus an inefficient search heuristic that is red for a given instance. Another point that is to be noted from the graph is the success probability of T steps. So when we add T steps, the probability that is optimum is found within this T steps. A search heuristic A is said to be efficient for the function f if a runtime grows on a polynomial function of the instance size. On the other hand, if runtime grows as an exponential function, then heuristic is said to be inefficient. So that means it has not to be an exponential function. Otherwise, it will become inefficient. Then we saw two of the algorithms that will come into the picture. One is the min-max and the other one is an alpha beta pruning. So as far as min-max is concerned, it is a recursive or a backtracking algorithm that will be helpful in decision making, especially in game theory. It provides an optimal move for the player, assuming that the optimum opponent is playing optimally. It is used where two-player games are considered, like chess, checkers, TikTok, and all those things. So one of the player will be max and the other player will be min. Both the players fight it out as the opponent player gives minimum benefit while they get maximum benefit. Both the players of the game are opponent to each other, so hence maximum will select the maximized value and the minimum will select the minimized value. The minimax algorithm proceeds all the way down to the terminal node of the tree. Then the backtrack. The tree is also called as recursive. This is the working. Let us take an example through the step 1. So we'll be having these steps. So step 1 is nothing but A is the initial state of the tree. So A is at the maximizer, whereas the worst case value is minus infinity. And the second one is a minimizer whose worst case initial value is plus infinity. So if you consider for the node D, it will be -1 minus infinity. And in this case, the value will be -1 and 4, out of which the max will be 4. Similarly, for E, max is 6. For node F, max is -3. For node G, max is 7. Now, if you go to in the reverse order, we'll go to B and C. So for node B, it will be D and E, which is having 4 and 6. The minimum value will be 4 because the second level is a minimizer level. Whereas node C will be -3 and 7. So in this case, the minimum will be -3 as it is the minimizer level. So the value will be -3. In this step, we will be considering node A. Now node A will be having 4 and -3, where the maximum will be 4. And henceforth, we complete the workflow of maximum 2-player game. These are the properties. One is complete. The second one is optimal. The third one is time complexity, that is OB raised to M. And then the space complexity, OBM. Limitations, it is slow for the complex games like chess. It has a huge branching factor. Hence, there will be a lot of choices to decide. Hence, in order to remove all these limitations, we move on to the next algorithm called as alpha beta pruning. Alpha beta pruning is nothing but the modified version of minimax algorithm. It is an optimization technique for minimax algorithm. Since we cannot eliminate the exponent, but we can cut it to half. Hence, in this technique, without checking each node of the game tree, we can compute the correct minimax decision, and the technique is called as pruning. What is happening in case of the minimax algorithm is that each and every node comes into the picture, hence the algorithm becomes slow. So in this case, what will happen is that only those nodes will be considered which is having very important or on which the value depends. The other things will be avoided. This technique is called as pruning. So this involves two threshold parameters, alpha and beta for future expansion, that is called as alpha beta pruning. Hence, it is also called as alpha beta algorithm. There are two parameters. One is the alpha, which is having the highest value, and the beta that is having the lowest value. So obviously, as it is having the highest value, the path will be maximizer, but the worst value will be minus infinity. Beta will be having the lowest value choice as it is a minimizer, but the initial value, or I could say the worst case value, will be plus infinity. The alpha beta pruning returns the same move to the standard algorithm does, as it removes all those nodes which are not affecting the final decision. Hence, by pruning these nodes, we can make algorithm work fast. What is the condition? The main condition for the alpha beta pruning is alpha should be greater than or equal to beta. The max player key points will not update the value of alpha. Minimum player will only update the value of beta. Max player will only update the value of alpha. While backtracking, the node values will pass to the upper nodes instead of values of alpha and beta. And we will pass only alpha, beta values to the child nodes. Now you can take an example of alpha beta pruning. In step 1, alpha is nothing but minus infinity and beta is equal to plus infinity. As alpha's worst case value is minus infinity and beta's worst case value is plus infinity. Hence alpha will be minus infinity and beta will be plus infinity. Now node B will go towards the child node D. From B, it will go to the child node D. Now, from A to B, the value will be passed as it is, like alpha equal to minus infinity, but beta value is 3. Now, from B to D, the alpha value will be 3. At node D, the value of the alpha will calculate at its max, right? So what will happen is that when it will come to D, it will have a maximum 2 out of 2 and 3, 3 will be maximum. Hence alpha will be equal to 3 and beta will be equal to infinity. Are you getting it? Now, as D is having the maximum value, it will return to B as beta will change the term into minimum. So it will be having infinity and 3. So out of which 3 will be maximum. So now in this case, alpha will be equal to minus infinity and beta will be equal to 3. क्योंकि वो रिटर्न जा रहा है. Now from B it will go to E. Now in this case, alpha will be equal to 5 and beta will be equal to 3. So if alpha is greater than beta, the right successor of E will be pruned and algorithm will not traverse it, and the value of the node E will be 5. So what will happen is that A, B, then it will go to D, from D to B, and then it will go to E, and E will stop here. It will not get to the another. Now from A to C, what will happen? Alpha is equal to 3, beta is equal to infinity, because we are on the right side. So alpha is equal to 3, beta is equal to infinity. Now when we move to the right side, we'll be having alpha equal to 3 and beta equal to infinity. From C, it will move to F. Again, alpha equal to 3, beta equal to infinity. Now in this case, it will be having a 0 and 1 value. So the 0 will be 0 and 1 value. So 1 will be returned to the F. So it will be having 3 and 0. So out of which 3 will be greater. So 3 will move to C. And accordingly, now at C, it will be 3 equal to alpha and beta equal to infinity. Right? So now here we have got the value, which is nothing but again, alpha greater than beta. Right? Alpha is greater than beta. So, but the node F will become as 1. So in this way, the node 6 will be carried out. Now, as far as 7 is concerned, now in this case, what will happen is that alpha is equal to 3 and beta is equal to 1. In this case, alpha is greater than beta, and henceforth it will traverse here only. It will not continue. So this algorithm will not complete the entire subtree of G. So what will be the path? The path will be equal to A, B, D, and 3. Have you got it? So in this way, we can calculate alpha beta pruning. Hope you have understood it. So what is the working of alpha beta pruning? So the alpha beta pruning is highly dependent on the order in which the node is examined. So there are two types of orders that could be. One is the worst ordering and the second one is an ideal ordering. So the time complexity of the worst ordering will be O b raised to m, whereas the complexity in an ideal ordering will be O b m raised to 2. What are the rules for the good ordering? Because we know we need good ordering. The best move from the shallowest node. Order the nodes in the tree such that best nodes are checked first. Use the domain knowledge while finding the best move. And we can bookkeep the states, as there is a possibility that states may repeat. So these are some of the rules for to find out the good ordering. So in this way, we have revised completely in 1 hour unit number 2. So now we'll move to unit number 3. Okay. So after complete revision of unit number 2, we'll move to a new unit. So today we'll be having this beginning or commencement of the third unit called as knowledge, representation, and reasoning. So a little bit we'll go slow by slow, as this unit is very much dependent on the intelligence. Because if you have knowledge and if you represent your knowledge, if you have a reasoning, then your common sense increases. That means your knowledge increases. In turns, your logic increases. And that is what the artificial intelligence is about. So unit number 3 is about the knowledge, about the intelligence, making machine the intelligence. So how you're going to, just a moment. Okay. So actually we are moving to unit number 3, which is nothing but knowledge, representation, and reasoning. So in interviews, actually, what company check is about your reasoning, logical reasoning ability. So reasoning plays a very important role as far as your understanding is concerned. So what is knowledge? What is the knowledge representation? And then what is reasoning? And then we combine together knowledge, representation, and reasoning. Then this unit comes to be as unit number 3. So now what we are going to see is step by step about what knowledge is, what representation is, what reasoning is, and how they are used in artificial intelligence. Leveraging the capabilities of AI, machines are now being designed to be smart and capable of performing tasks similar to humans. Obviously, as we are moving towards artificial intelligence, machines' capability has been increased similar to humans. And every new invention is helping to extend the frontier of AI in software, machines, technology, as well as knowledge. So up till now, you might have seen software, machine, technology, but a new word has arrived here is the knowledge. So now where this knowledge is going to play an important role. They too are collaborating with humans to help them accomplish various tasks that are very similar, earlierly unimaginable or limited to fiction. Right? So because of this artificial intelligence, machine and knowledge and all those things, Those tasks which were impossible for machines, the machines have started doing it, which were unimaginable, but now it is possible. So how this has been possible? Who made this possible? So one of the key player in this entire process is knowledge representation and reasoning. So it is one of the most important unit as far as understanding is concerned. Now, if we go back to definition of AI, we know that it is the study of intelligent behavior achieved through the computational means. Now, where the knowledge representation actually comes there, where the reasoning comes there. As we know that AI is the study of intelligent behavior that is achieved through the computational means. Knowledge representation and reasoning is a part of an AI, and that is concerned with how an agent uses what it knows in deciding what to do. जो तुम्हें पता है उसका इस्तेमाल करके डिसाइड करना कि क्या करना है क्या नहीं करना है, that is the knowledge representation and reasoning. आपको नॉलेज नहीं है तो आप तय नहीं कर पाओगे कि क्या करना है, लेकिन अगर आपको उस चीज का नॉलेज है तो आप ये तय करोगे कि उस नॉलेज का इस्तेमाल करके मैं क्या डिसीजन तक पहुंच सकता हूं. So how through this entire process the knowledge representation reasoning is going to help? How to decide what to do? It is the study of thinking as a computational process. So how we think, human thinks, similarly the computers think like in through a computational process. So what we think are human thinking. But in case of artificial intelligence, what is the thinking in that term? It is computational process. There is symbolical structure. There are symbolical structures invented for representing knowledge. Now, if I'm having a knowledge, but show me how the knowledge is. So there should be some kind of representation. So there are symbolic structures that is invented for representing knowledge, and to the computational process, it has devised for reasoning with those symbolic structures. Clear cut, I want to say that through this whole thing, that AI is nothing but the study of intelligent behavior that is achieved through the computational mean. Knowledge representation and reasoning, which is a part of an AI, is concerned about how the agent uses the knowledge to decide what to do. It is the study of thinking as a computational process. So, how this knowledge representation is possible? Through the symbolic structures. How this computational process is possible? Through the symbolic structures. How reasoning is possible? Through these symbolic structures. So the representation of knowledge, representation and reasoning, knowledge, computational process and reasoning could be done with the help of symbolic structures. Have you got up till this? Yes, have you got it? We are into the third unit. We are into the knowledge, representation and reasoning. Now we have seen why AI is becoming very intelligent, because now machines are being able to design in such a way that they have become smart, capable of performing tasks like human. So earlier we have seen that AI is nothing but a software machine technology, but now we are using a word called as knowledge. The tasks which were unimaginable to do, now it is possible with the help of machine and AI. And in this entire process, one of the most important processes is knowledge representation and reasoning. As we know that AI is nothing but the study of intelligent behavior that is achieved through the computational means. Knowledge representation and reasoning, which is a part of AI, is about an agent using the knowledge and deciding what to do. Now, how this is possible? Obviously, there are symbolical structures that have been used for representing knowledge, computational process, as well as reasoning. So ये जो slide है, इसका पतितार्थ यानी summary मैंने आपको बताई कि knowledge, representation and reasoning ये symbolic structure के through represent कर सकते हैं, और computational processing one of the things where the thinking will come into the picture. So computational process, computer का मतलब human thinking, both are same. Now let us understand the AI knowledge cycle. So when we move towards the human intelligence, obviously the knowledge will take a very important role. And when we say that knowledge should be represented, there is a way of doing it. So how it is to be done? So knowledge representation and reasoning is needed to create an intelligent machine. I said already, which makes it a crucial part of AI. So आपका knowledge ही आपको intelligence बनाता है. तो similarly AI with your knowledge will make you intelligent. So when a human is said to be intelligent, when he's having a knowledge. So the knowledge is checked and then we say that yes, this human is intelligent. So similarly, when the knowledge will be checked of the machines, then it is nothing but artificial intelligence. So that means they are required to create an intelligence of the machine, and henceforth becomes a very crucial part of AI. However, it is not only the component that is responsible for making machine intelligence. Obviously, it is not all the part, like it is not the complete thing that is required. Beyond that, there are different things which will make it intelligent. But yes, it is one of the most important part as far as the machine intelligence is concerned. Almost all AI systems consist of following components, which will use to create an intelligent machine. So how it is? So you can see there is a perception. So perception block diagram will lead to two more block diagrams called as learning and knowledge representation. So your perception is attached with learning and knowledge representation, whereas your knowledge representation is related with the reasoning. If your reasoning is said to be said, then reasoning is again goes to planning and then education, whereas reasoning is can be also given to an education. Now here the most important part is this, the block which has been marked here with the dotted lines. This is nothing but knowledge and representation. So I could say that it is the most important part as far as the understanding is concerned, the learning is concerned, and the planning is concerned. It is the part between learning and planning. And obviously it is based on the perception. Now, what is perception? The first component of the cycle is the perception. Now, for what purpose this perception is used? To get the information from its environment. हमने already देखा है, we have seen these things, perception, as far as the unit number 1 is concerned, where we were getting the inputs from the environments. So there were the perception concern. So it is nothing but the system to get an information from its environment, which could be either in the form of visuals, audios, or the other form of sensory information. So it is like in getting the information from the sensors, and the sensors are taking the information from the environment. So the perception is done. So that means the information is taken now. Then we will start learning. So the learning common component is adaptive, helps draw trends from recursive data. So it will learn from the data that has been captured from perception. The perception is nothing but to get the information from its environment. So now the learning component is very adaptive. It will take that information and it will start learning. So this is the step number 2, to learn from the acquired data. We are acquiring data and we are learning from the acquired data. Right? These two things are over. Now, third point, knowledge representation and reasoning. Now, there are some of the functions that has been carried out here. So after collecting information, the system forms a meaningful representation, which can be either static or coupled with a learning component. So सबसे पहले जो इंफॉर्मेशन कलेक्ट हुई है उसका एक मीनिंगफुल रिप्रेजेंटेशन बनाना जरूरी है. तो वो स्टैटिक भी हो सकता है, कपल्ड भी हो सकता है. स्टैटिक यानी वो खुद भी रहेगा, कपल्ड यानी कि वो ऊपर वाले लर्निंग कंपोनेंट के साथ मिलकर बनाएगा, तय करना है वो। पर नॉलेज हमको मिल गया है, हमने उसको पढ़ा है, लर्न किया है। अभी नॉलेज रिप्रेजेंटेशन और रीजनिंग से हम उसको रिप्रेजेंट कर रहे हैं इन अ मीनिंगफुल वे. So how it could do, it can do it alone also, or it could do in a combination of the learning component also. Additionally, knowledge representation and reasoning coupled together and intrinsically tied to each other. They will be combinedly working together. So what I could say that knowledge, representation, reasoning, and learning. So first will be learning, then knowledge representation and reasoning. They all three will come together and they will be coupled together in order to work out intrinsically. The other two phases of the cycle are planning and execution. So अब दो और बचते हैं, एक तो plan करना, एक तो execution करना. So they are dependent on analysis of knowledge representation and learning. So इसमें देखोगे आप कि planning जो है वो education, sorry वो education गलत हो गया है वहां पर, it should be execution. The other two phases of the cycle are planning and execution, which are dependent on the analysis of the knowledge representation and reasoning. So obviously नीचे का जो depend है वो planning और execute करना, वो तो सब कुछ knowledge representation और reasoning पे depend है, बराबर. So सबसे पहले हम क्या कर रहे हैं, perception. मतलब we are gathering the information, we are collecting the information from its environment. That may be in a form of visual, audio, or any other sensory information. Then the learning component will start, be an adaptive, and it will learn from the data. But the data is raw data. So what will happen? Knowledge representation and reasoning will collect all the information and put it in a meaningful representation. It could do it by static, or it could be do a combination of learning component. So that could be a combination of learning, knowledge, representation, and reasoning. All these three tied together. And the other two phases of the cycle, which is planning and execution, are dependent on the analysis of knowledge, reasoning, and representation. Obviously, the last two, planning and execution, depends on this third. So the heart of the picture about this cycle is the third block, which is nothing but knowledge, representation, and reasoning. Now the fourth step is a planning. Now when I know that there is a knowledge, representation, and reasoning, now I'll go for the planning. Once a useful representation is made, the information is used to plan a course of action. Yes, planning बनना शुरू हो जाएगी, क्योंकि अब हमने information को अच्छी तरह से represent किया है और इसके आगे अभी planning execute होगी. Fifth one is the execution. Finally, the planned action is executed, which enables the machine to perform the intended task, and then the execution will be done. So जो task दिया है, अब वो task perform करने के लिए हम लोग ready हैं. So where we are here. We are in the unit number 3 and the unit number 3 is here. क्योंकि आपको पता चलना बहुत जरूरी है कि हम क्या पढ़ रहे हैं, हम क्यों पढ़ रहे हैं, और वो किस जगह पे है, वो किस जगह पे एप्लीकेबल है. सो ऑब्वियसली इस जगह पर वो एप्लीकेबल है, यहाँ पर. सो ह्यूमंस को इंटेलिजेंस बनाने के लिए हम जो थिंकिंग की जरूरत पड़ती है, एक प्रोसेस की जरूरत पड़ती है, उसी तरह से जब कंप्यूटर्स को इंटेलिजेंस या मशीन्स को इंटेलिजेंस बनाना है तो कंप्यूटेशनल प्रोसेस की जरूरत पड़ेगी जो कि उनकी थिंकिंग होगी, और उस हिसाब से फिर हम इंटेलिजेंस डेवलप कर सकते हैं उस मशीन का. अंडरस्टैंडिंग? The diagram in the previous slide is showing how an AI system can interact with the real world and what components helps it to show intelligence. So yes, what the diagram we have seen is about interacting with the real world, that is nothing but the environment, and the what components are there actually which helps it to show its intelligence. The AI system has a perception component by which it retrieves information from the environment, which could be audio, visual, sensory, and all those things. The learning component responsible to capture the data, study the by perception comportment. So study karna, learn karna, to learning component. In the complete cycle, the main component is knowledge, representation, and reasoning. The two components are involved in showing the intelligence in machines like humans. जैसे मैंने बताया कि reasoning नॉलेज, यही तो इंटेलिजेंस बताते हैं। तो कंप्यूटर का इंटेलिजेंस बताना है तो आपको ये लगेगा नॉलेज, रीजनिंग, representation. These two components are independent with each other but also coupled together. The planning and execution depends on the analysis of knowledge, representation, and reasoning. Now let us go step by step. Let us little bit break each and everything. And when we break it, we can come to know a little more clear. So what is knowledge? When I say that you are having a knowledge, what does it mean? It means taking the world to be one way and not the other. One way, not the other. So जो चीज है और वो आपको पता है, जो चीज ऑलरेडी है वो आपको पता है और आप उसे ले रहे हो by one way, that is not the another way. तो दूसरे वे से आप नहीं ले रहे हो क्योंकि वो हो ही नहीं सकता है वो पार्ट. So in this means, what does it mean? It means that I'm going to take the world by one way, not the another way. So knowledge को अगर define करना है, this is only one way you can define. It means taking the world in one way, not the other way. Now, what is representation? Representation is the relationship between two domains, where the first is meant to stand for or take the place of the second. So representation is stand for and take the place of the second. So stand for and take the place of the second. Usually the first domain, the representer is more concrete, immediate or accessible in some way than the second. यानी पहला जो है वो दूसरे से बहुत अच्छा है. Actually, representation is the relationship between the first and second. And first one जो है वो बहुत concrete है, बहुत solid है, accessible है as compared to second. जो one way बोलता हूं ना मैं, as compared to the not another. So यहाँ पर first and second के बीच में जो relationship देता है वो representation है. The first domain representer is more concrete and immediate and accessible, whereas the second one in some way. The type of representer that will allow the most concern with here is the formal symbol. That is, character or group of characters taken from predetermined alphabet. So obvious represent करना है तो किसी न किसी चीज से आपको represent करना पड़ेगा. तो कैसे करोगे आप? Through symbols. It may be through characters or it may be through group of characters. Understanding? The digit 7, for example, stands for number 7 and does the group of letter 7. So how could 7 be represented? It could be represented, the digit 7 can be represented as a number 7. And or a group of letters like 7. दोनों तरीके से आप उसको देख सकते हो ना. अगर मैं digit 7 की बात करता हूं तो number 7 भी है और group of letter 7 भी है. That is nothing but representation. As with all representations, it is assumed to be easier to deal with symbol, recognize them, distinguish them from each other, or display them than with that what the symbol represents. Symbols एक easy way है representation के लिए. हमने पहले भी देखा है कई concepts में जहां पर हमने देखा कि symbol जो representation है वो बहुत काम में आता है. किस लिए आता है? क्योंकि वो रिकॉग्नाइज होते हैं इजीली, वो डिस्टिंग्विश कर सकते हैं, वो डिस्प्ले करने के लिए भी काम में आते हैं. इसीलिए रिप्रेजेंटेशन का सबसे बेस्ट तरीका है यूजिंग सिंबल्स. और सिंबल्स रिप्रेजेंट कर सकेंगे तो आपका रिप्रेजेंटेशन भी हो जाएगा. नाउ लेट अस सी सम ऑफ द बेनिफिट्स ऑफ रिप्रेजेंटेशन. जैसे मैंने बताया कि सिंबॉलिकली वो प्रेजेंट कर पा रहे हैं तो उनको हम रिप्रेजेंटेशन बोलते हैं. तो उनके कुछ बेनिफिट्स है. For example, we can add new tasks and easily make them depend on the previous knowledge. Obviously, symbolically हम डाल रहे हैं तो हम easily नए टास्क बना सकते हैं और या previous task में भी नया टास्क ऐड कर सकते हैं because it is symbol representation. Second, extend the existing behavior by adding new beliefs. You can add also beliefs in that. Debug faulty behavior by locating the anonymous belief. So field faulty behavior भी आप easily ढूंढ सकते हो कि erroneous beliefs को find out करो तो faulty behavior मिल जाएगा आपको. Explain and justify the behavior of a system. Yes, through these representation you can find out or justify any system's behavior. ये system ऐसे काम क्यों करता है, किस लिए करता है. Representation means symbol standing for the things in the world. So I am representing myself is nothing but I'm symbol. I can add something in my head, get a knowledge, and then I'll represent in a very good way. I'm a very good communicator, so I will represent myself on the stage in a very nice. So representation is nothing but symbol standing. I'm like a symbol. And that is symbol standing for things in the world. This is how the representation actually goes with. Now knowledge representation. So now if we say what is knowledge, we say what is representation. Now the next concept comes is what is knowledge representation. Now knowledge representation is nothing but we want to represent by using some symbols that knowledge what I am having. So it is a symbolic encoding by some agent of propositions believed. So some of the symbolic encoding that could be used by the agents and that is believed. It is the area of AI that deals with the problems of representing, maintaining, and manipulating knowledge about an application domain. So problems of representing, maintaining, manipulating knowledge about the application domain. यानी मुझे एप्लीकेशन करना है, उस रिलेटेड कोई नॉलेज है, उसको मैं रिप्रेजेंट कर रहा हूँ, उसको मेंटेन भी कर रहा हूँ, उसको मैनिपुलेट भी कर रहा हूँ. ये सब अगर कर सकूंगा तो मैं बोलूंगा कि ये नॉलेज रिप्रेजेंटेशन है. Since virtually all AI systems have to address this problem. खास बात है कि ये सब AI systems को लगने वाला चीज है, ये जरूरत है AI systems को लगने वाली. So KR is one of the most central subfield of AI. Virtually every AI is needing to address this problem, and henceforth this knowledge representation is the central subfield of the AI. So main researchers जो है वो knowledge represents को कहाँ use कर रहे हैं, ये भी समझना जरूरी है. Where they are using. So they are representing knowledge about application areas like medical knowledge, knowledge about time, knowledge about physical systems. How they are representing? So they are representing knowledge in different application areas where it could be medical, it could be time, it could be physical systems. Developing appropriate representation languages. Yes, we can represent language also. So there also this KR can be used for representing languages. Specifying and analyzing reasoning or represented knowledge. So specifying and analyzing reasoning. जो नॉलेज रिप्रेजेंट किया है उसका रीजन देने का काम भी वो कर सकता है, उसका रीजनिंग इंप्लीमेंट हो सकता है. यू आर गोइंग टू एनालाइज द रीजनिंग, यू आर गोइंग टू स्पेसिफाई द रीजनिंग ओवर द रिप्रेजेंटेड नॉलेज. And much more thing is that implementing systems that support the representation of knowledge and reasoning over represented knowledge. So you have to implement the systems that will support this representation of knowledge and then reasoning over the representation of the knowledge. See, there are two things in this. First is your knowledge. Second is the representation. Third is the knowledge representation. And the fourth one is reasoning over the represented knowledge. These all things, four things will come together. and all are dependent on each other, because unless and until I have a knowledge, I cannot move. Unless and until I have a representation like symbols does represent, I cannot move forward. Then knowledge representation is again most important part. How you represent your knowledge. And the fourth one is reasoning over the represented knowledge. That will come into the picture. And henceforth, knowledge representation is a very, very important part. While knowledge about an application domain may be represented in varieties of forms, procedurally in the form of program code, or implicitly as a pattern of activation in the neural network, research in the area of knowledge representation assumes an explicit and declarative representation, an assumption that distinguishes KR from the research, programming language, and neural network. अगर एप्लीकेशन डोमेन में नॉलेज को रिप्रेजेंट करना है तो कौन से फॉर्म में हम रिप्रेजेंट कर सकते हैं? एप्लीकेशन डोमेन में नॉलेज को रिप्रेजेंट करना है तो कैसे कर सकते हैं? Patterns of activations, program code, pattern of activations in neural networks, research area, declarative representation, and then some of the programming languages and the neural network. All these ways, they are helpful to represent the knowledge about the application domain. Explicitness of representation means that represented knowledge is stored in a knowledge base consisting of set of formal entities that describe the knowledge in direct or unambiguous way. How you are going to represent this knowledge which has been stored? So how it is stored? Obviously in a knowledge base. How this knowledge base could be? The knowledge base could be describing the knowledge in a direct or unambiguous way. That is how it is seen. So the knowledge which you want to represent has to be stored somewhere. So it is stored in the knowledge base. Understanding? Declarative means that formal meaning of representation can be specified without references to how the knowledge is applied procedurally, implying some sort of logical method behind it. When you apply knowledge to a particular domain or application domain, there has to be a reason how it is applied, why it is to be applied. That is called as declarativeness. You have to declare why this knowledge has been applied, why this knowledge has been represented. And that is nothing but implying some sort of logical methodology behind it to implement this declarativeness. This is all about knowledge representation. So in the next lecture, we'll see reasoning. So we'll stop here. We'll take attendance.